A very good morning to all. In today's video, we will study our next chapter, that is sound. So, in this video, along with sound introduction, we will study how it is produced and how it propagates in a material medium.
You know that someone is standing outside your door when you hear the doorbell. The sound of the doorbell traveled to you. Can you guess how it traveled? It traveled through air. Yes, here the medium of propagation is air. Sound requires a medium for propagation. Is the medium always air? Not necessarily. The medium of propagation of sound can be solids, liquids or gases. Yes, sound can also travel through solids and liquids. Before we get to that, let us see some other examples of sound propagating through air. Remember, air is nothing but a mixture of gases. Sound of the siren when the train is approaching you, sound of glass breaking, sound of the firecracker, etc. are some of the examples where the medium of propagation is air. Sound can also propagate through liquids. Let us do one experiment to see this. We place the bell in the water like this so that it does not touch the base of the container. Now keep one of your ears close to the surface of water and shake the bell inside. Do you hear the sound? Yes, you do. Here, the medium of propagation is water. What instrument does the doctor use to check the rate of your heartbeat? Yes, it's called a stethoscope. Doctors place the small disc-shaped object called a turnable diaphragm against your chest. The sound of your heartbeat travels through the tube and can be heard from the two earpieces. So, can you guess the medium of propagation of sound here? Yes, here the medium of propagation is a solid. The tube through which the sound travels is the solid. Now suppose you're standing on one side of a brick wall and your friend on another side with one of his ears close to the surface of the wall. Hit the wall with some wooden object. Ask your friend if he hears the sound on the opposite side. I'm sure he will say yes. Here the medium of propagation is again a solid. So with the help of a few examples, we saw that sound can travel through solids, liquids and gases. But does it mean that sound can travel through anything and everything? The answer is resounding no. The sound cannot travel through vacuum. What is a vacuum? It is a space from where all or most of the matter is removed. Example is outer space. Yes, we cannot hear sound in outer space. That is why they say, in space, no one can hear you scream. In our previous video, we studied that sound needs a medium for propagation. That is, it requires some medium to travel from one place to another. But how does it really travel through the medium? What happens to the particles of the medium? Let us find out. We now know that sound is produced by vibration. When the object is vibrating, it sets the particles of the medium around into vibration. In the process, the nearest particles to the source gets displaced from their mean or equilibrium position. They start to collide with the particles adjacent to them. The adjacent particles then also get displaced from their mean positions. They in turn do the same to their neighboring particles. This process continues in the medium till the sound reaches our ear. We see that we create some disturbance flowing through the medium. This is the way that sound travels through the medium. We see that particles of the medium are not traveling from the source to the human ear. It is the disturbance produced by a source which is traveling in the medium. The particles are merely oscillating from their mean positions. This disturbance created by the vibrating object in the medium is what we call a sound wave. But what does this disturbance look like? Let us study this with the help of a tuning fork. Here we take air as a medium of propagation. Here we have a tuning fork made up of steel. This shows the initial condition of the air particles of the medium when the tuning fork is in its original position, that is, when tuning fork is not vibrating. When we strike its prong on a rubber band, we start hearing a sound. How does the sound travel through the medium? The two prongs of tuning fork are vibrating. Let us concentrate on motion of one of the prongs first. Say the one on the right. When it's away from its mean position, it pushes and compresses the air particles around it. This creates a high pressure region, also called compression. This compression travels in the medium as a disturbance. Here the density is high. That is, the particles are very close to each other. When the prong comes towards its mean position, the pressure on the right decreases and keeps on decreasing further as the prong continues its motion towards left. This creates a low pressure region, also called as rarefaction. We see that at this point, the compression in the form of disturbance has reached this region. This rarefaction also travels in the medium as a disturbance. Here the density of particles is less. That is, the particles are far away from each other. As it continues to vibrate, we get a series of these compressions and rarefactions. This continuous sequence of compressions and rarefactions is what we call sound waves. Yes, the sound waves travel in the form of compressions and rarefactions. Instead of the tuning fork, if we take any other source of sound, say the speaker, then the sound waves generated by this object will also travel in the form of compressions and rarefactions. Here is one interesting question. Is the sound wave a mechanical wave? Do you know what a mechanical wave is? The mechanical wave is a wave that requires some material medium to travel. And as we know, a sound wave also requires some medium to travel. So yes, it is a mechanical wave.